Hi everyone, we're going to find the power series representation for f of x equals 1 plus x divided by 1 minus x squared, and also find the radius of convergence. First thing we're going to do is look at let's just look at f of x equals 1 divided by 1 minus x squared. Now, the way we can find this one is take 1 divided by 1 minus x, and note that it equals 1 plus x squared plus x cubed plus dot dot dot. And that's going to equal the sum. All right. N equals 0 to infinity, and then we have x to the power of n. So basically, this one would be x to the power of 0, x to the power of 1, x to the power of 2, and so forth. All right, now if we differentiate both sides, you differentiate this is going to be 1 divided by 1 minus x squared, which is what we want. This is going to go away. So our x to the power of 0 is gone. And for this one, we're going to get just 1. So this is going to turn to 1. This one's going to turn to 2x. This one's going to be plus 3x squared. Plus dot 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 equals, but we're starting with the 1. So this is going to be n equals 1 to infinity. And then you differentiate this. This is going to be n times x to the power of n minus 1, just like you normally take the derivative. I can also write this as 1 divided by 1 minus x squared. And if I want to go back to 0 here, I can write this as, basically what I can do is substitute my n with n plus 1. So I can go back to 0, and that means I'm going to add 1 here. I've subtracted 1 here, add 1 here. And this is going to give you n plus 1 times x to the power of n. Now the radius of convergence is the same as our original series given here. And all we did was differentiate it. So the radius of convergence equals 1. Just stays the same. Now let's complete it with this in the numerator 1 plus x. So all I'm going to do is take this and write f of x equals 1 and split this up. I'm going to divide each of these terms by 1 minus x squared. All right, we already know what this is. We already got that earlier, so that's going to equal the sum from n equals 0 to infinity of n plus 1 times x to the power of n. And this is the same thing, except that we are multiplying it by x. So basically it's going to be the sum n equals 0 to infinity of n plus 1, and now it's x to the n times the x. And that's just going to equal x to the power of n plus 1. That's what this equals. So that's the only difference between the two. Now, to make these both x to the power of n, what I'm going to do is write this as the sum n equals 0 to infinity of n plus 1 times x to the power of n, and I'm going to add 1 here, so I'm going to subtract 1 here. So that's going to end up being plus the sum n equals 1 to infinity, and we have n times x to the power of n. Okay, what I'm going to do next well, I think I could probably do it up here. Let's do it up here so we can see it. What I'm going to do is substitute in 0 first. If I substitute in 0, I'm going to get 1 times x to the 0, and that's going to give me 1. And then I'm going to start with n equals 1 to infinity, and I will have n plus 1 plus this n times x to the power of n. Now, the reason I wanted to do that is I want to simplify this. So all I had to do was first change my starting point here, and I had to move this 1 out. All right, so doing that, let's look at this. This is going to give you 1 plus the sum of n equals 1 to infinity of 2n plus 1 times x to the power of n. And then all I have to do, we're almost done, is subtract the 1 here and move this back to n equals 0. All right, and then we get the same thing. So your final answer is going to be, let me just do it on another slide. So your final answer is going to be the sum, and back to n equals 0, because I've subtracted that 1 to infinity, and then we still have 2n plus 1 times x to the power of n. And your radius of convergence still is 1. And that's it. Thank you. Have a nice day. Bye-bye.